not easy, like medium, like not hard for sure. It is given a string s and you have to partition s such that every substring of that partition, like that partition itself, it should be a palindrome. I'm going to return the all possible palindrome partitioning of s. So it is obvious that if you have, let's say, any string a b c, okay, let's say a b c a something, let's say, okay, a b c. Now you have to try, I will try partitioning maybe here, I will try partitioning maybe here, I will try partitioning maybe here, and so on and so forth. So basically I'm trying again, if you have some string, you can only cut the string from here itself, right? You will cut the string from here itself, or maybe you will cut the string from here. Okay, so roughly I can easily say that I will try to cut, I have an option to partition the string maybe here, or I have an option to partition the string maybe here, or ultimately, okay, in the worst case you have the entire string, which means, okay, partition in the end or maybe in the very beginning. This is the worst case, which is the entire string. So you realize that you have options. Whenever you have options, you try for all the options. So I realized I have options. I have options to partition the string. So I can say, okay, what if I partition at this first place? Yes or a no? Okay, if I will partition, so this left side will become as it is. It should become one substring. So left side became a substring. Now what if I don't choose to partition? Okay, which means this will not become one substring and it will try to extend on the right side. Okay, he tried to extend on the right side. Again, this is, I'm not saying this has become one substring. No, it will extend maybe on the right side. Okay, but this has become one substring, and if it has become one substring, it should be a palindrome. I will check right here that whenever I make a circle, it should be a palindrome. Now starting from here, I again have option. Should I partition here or not? Which means, should I place a partition here or not? Okay, let's place a partition. If I place a partition here, then what will happen? Okay, you will form one. Again, as you can see, I placed a partition here, which means this has become one substring. Okay, this has become one substring. Again, whenever any substring is being made, that should be a palindrome. That's a very big condition. Okay, and then you can easily see the remaining is one only, so that will it will have to come. What if I don't plan to do a partition here? What if I don't plan to do a partition? Which means the partition will not be happening here. If the partition will not happen here, so for sure I will not be putting any mark. And then ultimately, again, as you can see, the string ended here. So for sure, this last one should come inside and should make one substring. So this should be a palindrome, which means this last one, but it is not. Okay, it is not, but it's not a palindrome. The same way here, I choose, okay, what if I put a partition here? Okay, if I put a partition, which means this left portion should be one substring. If it is one substring, go and again check if it is a palindrome or not. Okay, yeah, A is a palindrome, so I'm good. And then remaining one, you can just put it as it is. What if I don't plan to do a partition here, which means there's no partition, so it will extend. If it will extend, so for sure it will become a AAB, and as it has ended, so I can make it as a one substring or one string, and then it is not a palindrome. So we realize that these are the two answers for us, which are following the property that every substring is a palindrome. So now if I ask you what is the complexity for it, you will easily see the complexity is nothing but at every gap you have options: do a partition or don't do a partition, as in extend the string, extend the substring. So we simply can see that I will have, if I have a string with n characters, I will have n-1 gaps. For every gap I have two options: either choose that, either do partition at that specific gap or don't do the partition. So I easily can say, if I simply apply a recursion, simple recursion, I will end up having complexity of 2 raised to power n-1 to generate all the possible options. Okay, now but there is a bit thing. Okay, I have just showed you right now that what is the maximum possible complexity, right? This, and we can easily see that our n is very small, so simple recursion would also work. But it is not only about the recursion. it's also about that on every recursion, you also have to check. You also have to check if that string is a palindrome or not. And in these cases, when I told, okay, what if I extend? I told, what if I extend it? Here, as you can see, as you remembered, I gave you two options. What if I do a partition here, which means I fixed it and then I checked. As soon as I did a breakpoint and I know it's a partition, so I will have to check if it's a palindrome or not. But there was other case. What if I extend this? Which means I can extend this. Okay, it can try maybe for A, B. What if I had C, D, E, F? Then it would have extended and tried for AAB, AAC, AAD, AAE, AAF. It would have tried for everything, and then maybe made its own recursive tree, and again it would have gone down. So for these kind of cases, just to do a small pruning, I'm again saying it's a very small pruning. It will just prune just maybe one level. So what we can do, as we were actually trying to do partition at every step, I might even try doing and say, okay, bro, only grab those substrings which are actually palindrome. So I remembered I have these options. I can partition here. So I will say, okay, I will try and see if I take this as my substring, as my left substring, will this work or not? So I took a partition here. What if I take this as my left substring? Okay. Again, what if I take this as my left substring? Okay. So I'm just in the very beginning asking if this as a left substring will work or not. If not, then I will not even try for its remaining right part itself. Again, it's a very small pruning. It will just prune one level. It will not affect the complexity at all. Complexity will still remain as it is, but it will just show you a very easy way to compare stuff. So you realize at every step, I will just go on to all the possible partition places, which means I will try this AA, AA, AAB, right? And then I will say, okay, is this a palindrome? Yeah. Palindrome? Yeah. Oh, not. Okay. So don't even try for other stuff here. Here also I will try if A is a palindrome, A is a palindrome, which means, okay, I'll try partition here, here, and so on and so forth, which is the same replica as that of the above. Again, people get confused. What is the complexity of this? Because here you can see there are three options available, and maybe what happened here. So people get confused in complexity. Complexity is still the same. It will still go and try for 2 raised by n-1 options. Still the same. It's just that representation way is a bit different. I have to teach you, okay, this is also a way which you can represent. And again, complexity will still remain same as we had of take, not take, which means do a partition and not do a partition. So ultimately, this is the only stuff. Again, there is nothing to memorize here because you will have to go and try for every such partition and see if it's a correct palindrome partition or not. Now, how will you write the code for this? It's very simple. In the very beginning, you will start off with the index 0. So I can simply say I start off from the index 0. Now, okay, now I have to make sure I have to try for all the possible left strings. So in my, again, this is my main function in which I will go and call my solve function. In my actual solve function, again, this will not return anything because I ultimately have to grab all these final strings itself, which means my final string answer should contain a AAB and a AAB, right? Again, this AA is together and this AA are different. Cool. So I will just simply have a void function in which I will make a global variable or maybe some big vector of vector, which will stay. Again, as you can see, this is the vector of strings. This is also a vector of strings. And my answer should contain all these vector of strings. So basically my answer is itself a vector of strings. So this is my final answer. So what I told my answer is that, bro, I will give you an index I, right? You have to go, let's name it as ID. You have to go and try from that index ID. You can try for different end. What if the end is this? What if the end is this? What if the end is this? So what my code is going and trying is, my code will go and try for all end starting from the ID itself. And I know that end can go up to the length of the string. Length of the string is, let's say, n. And then end plus plus. Now, firstly go and check if that string from ID to end if that is a palindrome or not. So I'll just check if that string s from id to this end, if that string is a palindrome, okay, I can just put it as a left part, put it as my left part. So I will say, bro, I will put this as my left part, which means that this will go in this vector of strings. So I will have to maintain another vector of string, which means this specific string, vector of string. So I will say, okay, bro, I am maintaining a vector of, again, I am maintaining a vector of string called as, let's say, path, or maybe you can say the one substring, one answer you can say. And again, for all such paths, I have to store it in my final vector of string, which is my answer. So answer will store all the paths, and path will store every piece of good string, which is actually a palindrome. Cool. So I will simply say, bro, that this is actually this, if it is a palindrome, which means s from id to end, id, let's say end was here, id to end, if that portion is a palindrome, so this should go inside my path. As you can see, this will go inside my path, because this vector of string path here contained a and then a b, so it should ideally go inside my path. So I'll simply say that path dot pushback string from id to end. And you can see in C++, again, for every language it's very simple. In C++ it is s dot substring. You have to grab the string s, length should be this. Okay, I am saying that the string s, where id is here, end is here, I want to grab this as a portion of substring. So it is end minus id plus 1. This is the length of that specific substring. This is how we usually do in C++. In Java, it's just the index. Now, when this portion is done, you have pushed back this specific. And now you will simply go and ask your recursion to go and try to solve starting from the next index. If you have broke at this id, this end point, the next index is end plus 1. This is end plus 1. This is the next index you will start off from. So I will simply go and say and ask my recursion, bro, start from end plus 1. That's it. Now, it might seem like it's okay, but you will see that you will have to maintain this path. So it's ideally saying that I'm kind of pushing this string AA in my path, and then maybe I'm trying for different stuff. Although in this case I had only B, so what if it's good, but it will go and try for AAA, but then it's a recursion, so it will go up, and then it has to go and try for AB. So either you have to make a new vector altogether starting from root, which will for sure duplicate the vector, and that is the use of backtracking. That whenever we know that we have to push something in my path or maybe in my temporary answer, I will push it, and I know as soon as I have reached my leaf, I will push this path in my answer, and then I kind of, as I go up, I should remove what I have pushed recently. That is the beauty of backtracking. If you don't understand this, please go and watch this video, because this is a bit harder problem to understand backtracking as an example. Cool. Now we know that, okay, it's very sorted that when I will go up, I will simply remove that from my path. So I will simply remove that, which means simply a pop back, remove from the end, and that's it. Simple base case, as soon as I have reached my end, which means my id is actually equal to end, then I will simply say in my answer, just push back that path, which is a vector of strings, and voila, that's done. Now complexity, simple. We know that this tree will have complexity of 2 raised to power n minus 1, but at every point I am going and checking that specific substring from id to end, if that's a palindrome or not. So that will take a O of n time, because I have to kind of compare both the ends. If you don't know what's a palindrome, how to compare the palindrome, palindrome is something which is same from starting and the ending. So we use simple 2 pointers to compare both the strings, and if it is a palindrome, okay, I'll say it is a palindrome. So I should say, okay, that is number of strings which I could have. Ultimately, for everything I will have to kind of go and check if that's a palindrome, so it's a O of n time. If it's a palindrome, then I will make a substring out of it. As you can see, I will first check if it's a palindrome. If yes, then I will make a substring. So this will take O of n time, this will take O of n time. So I know my entire recursion combined, make sure, please don't say Aryan, this is id which is 2 raised power n and this is another for loop which is n, so it should be 2 raised power n into n for this and then n plus n for these, n plus n for these. Nah, that's the reason I told you this is nothing but 2 raised power n, because you have options to put on a partition, which means at a partition you will either place it or not place it. So it will be only 2 raised power n. Combining these two, which means this and this, combining them, it will be a 2 raised power n. I showed you why by showing you that how it links to take not take. Cool, and that's the code itself. Let's see the code. It's pretty simple. Firstly, I made an answer, which is if it's empty, simply return the answer. Then I make a path, which is my path itself. Now I could simply call from the index 0 and said that this is my string, this is my path, this is my answer. I will pass everything by address. As you can see, I passed everything by address. Okay, sorry, this is not. I passed everything by address. That is the beauty of backtracking, that you are able to pass this path by address. The beauty of backtracking is, else you would have to make a copy of path again and again, which would have incurred another O of n time complexity. Cool. So then you went on and simply asked the simple that, okay, try for the end index, starting from the current index, which is id, up till the length of the string, and then n plus plus. If it's a palindrome, then go and make a string out of that, starting from the index to the end, make a string and then push that in the path. Go and again try for your solve function, then ultimately remove that from the end from your path. Again, this is palindrome, is a simple function which you know that there's a string from starting to ending. You have to just compare if it's a palindrome or not, which means you can simply use a 2 pointer, compare both the strings from the end. If they are same, keep on going, keep on going, keep on going. If they're not same, it's not a palindrome. So I simply went on from start and end. I compare if something is not equal. Okay, bro, simply return a false here only. Else simply, ultimately in the end, when everything is same, left and right, then you can simply return a true. Okay, again, this will take a O of n time. Make sure that part. Okay, and again, so I realized that, okay, to check if it's a palindrome or not, if it is taking O of n time, then when I have checked it, so this again operation will take O of n time to make a string out of that specific main string. To make a substring from start to end, it will take O of n time. Ultimately, as soon as I've reached my end, I will simply push the current path, which is this specific vector of string, in my answer, ultimately return. Now, you very easily know what's the complexity. Complexity is that you know that this simple thing, index and this thing combined for loop, this will take 2 raised power n minus 1 time, or you can say 2 raised power n time, to be more simple. On top of it, on every of these iterations, I'm just checking if it's a palindrome or not, and then if yes, then I will make a substring out of it. So this is the time complexity of our approach. So the time complexity is at 2 raised power n minus 1, or you can say 2 raised power n also, into n plus n. N is to firstly check the palindrome, and next n is to make the substring, or make the string. Space, as you know, it's a simple recursion. So the recursive depth space will be how many partitions I can make, and I have a string of length n. So worst case, I can make n minus 1 partition, or I can say n partitions. So the recursive depth can go up till a size of O of n. So the approach which you have seen right now will take a time and space like this. Can we improvise it? Yeah, obviously we can, because we easily see one very basic stuff, that we are checking the is palindrome again and again. We know that we have a string of length 16. We can pre-compute again. What this do? This takes a start and end of a string. If this is a string, it will take some start and some end, and then it will check if that substring is a palindrome or not, right? So why not I pre-compute this? Why? Again, you can see a 2 raised power n into n. This is the extra factor I'm actually incorporating to just check if something is a palindrome or not, which means I'm checking palindrome for 2 raised power n number of times. Now I'm saying do a pre-computation and check the palindrome only for the n square substrings, and we know n square is much less than 2 raised power n. So this is how I can improve my complexity, because I know that this thing is simply repeating for every possible partition. So I will simply, what I'll do, I'll simply go and try for all the n square substrings. Simply, if you don't know how to get to the n square substring, it is I equal to 0, I is less than n, I plus plus, and then for int j equal to 0, j is equals to I, j is less than n, and then j plus plus, and then you know that the current substring, let's say int s temp, it is s dot substring starting from the index I, length will be j minus I plus 1. This is the current substring. Now you will just simply check if this is a palindrome or not. If this is a palindrome or not, which means s temp is a palindrome or not, right? If yes, then you will simply say that I to j, or you can simply maintain a check is okay or is palindrome like this, that I to j is equals to true. Just maintain, just write this in your main function. That's it. That is it. With this, you will simply go on to all the n square substrings. For every, you will simply check if that's a palindrome or not. So of n square into n. Again, space use will be O of n square because of the pre-computation, because you can simply see you have to make a 2D vector I to j, but that's a very small thing. And with that, by simply increasing the space and reducing the time, because by reducing time, earlier you saw the time was at 2 to the power n into n plus n, but now time will be 2 to the power n into n is to make the substring. It is to make the substring, but to check the palindrome, this is now removed. Because I have pre-computed this, and this pre-computation has taken a O of n cube time, and thus it is a better time complexity. Again, the space has improved, the space have increased because of the space used by pre-computation, which is O of n square, and that's how you can simply improvise it in the answer. Again, that's not a big improvisation, but yeah, still it will actually help you to showcase it's a good optimization. Cool. I hope you guys got it. If you have any doubts in backtracking or bit manipulation, we have crash course for both of them, backtracking and bit manipulation crash courses. I highly recommend, please go and watch it out, and see you. Goodbye, take care, bye bye. If you have not joined the Discord, make sure to join the Discord, in which we discuss the problems, community, and also any doubts, issues, questions, queries, you can also put it there. Bye bye.